Hello, grade 7. How are you today? I hope you all are safe and well. We studied before about soil, and we said that soil is made up of rock fragments, humus, living things, air, and water. We said also the main types of soil are clay soil, loam soil, and sand soil. Each one of them has its own properties when it comes to water drainage and the texture. We mentioned that sandy soil feels gritty, clay soil feels sticky when it's wet and hard when it's dry, and we said that dry, silty soils feels floury. And we even said that we can test to know or to identify the types of the soils for these textures and the drainage of the water, which one of them like draining water more or which one of them is draining water less. We also said that we can separate the soil compounds by adding water to soil and shaking. Each layer will form or will be separated alone. Today we will talk more about soil, and we will see the soil contents or the water in the content and the air content inside them. So please open your books on page 68, grab your highlighters and follow me. More about soil. Soil water content. So we mentioned that it contains water. So how much water we have? Different types of soil can hold different amounts of water in their pores, which is like the gaps between the solid matter or the spaces. Sandy soil holds very little water. Why? Because it's full of air. We mentioned before that it can suck the air in, the water in easily. So that's why it holds very little water inside it. And clay soils hold more water because if it's wet, it will not drain the water down, so it will hold more water inside it. The tables show the percentage of soil that is water for the three different soil samples. So we have different soil samples. We have sand soil, loam soil, and we have clay soil. Here we have the percentage of soil that is water when the smallest pores are filled with water and the biggest pores are filled with air and water. We have here 7% of it here inside the sand soil. We have 18, and the clay we have 23. That means the 23% is the highest percentage of water that the clay could contain. Okay, we talked about the water content. What about the air content here? The amount of air in a sample of soil depends on how wet the soil is. So if the soil is wet, these pores could be filled with water, so they will replace the air. So here, soil pores can be filled with air or water. The more water in a soil, the less space there is for air. So if the water gets in, the air will get out. They will replace each other. Pavan and Paddle take soil samples to school. They want to compare the amounts of air in the two soils. This is what they do. So here these two students, they took two samples for soil, the same soil, and they for different soil, sorry, and they want to see the contents or the amount of air in these two soils. So first they placed 100 cubic centimeter soil in a measuring cylinder. And why they're using measuring cylinder? Why they're not using beaker? Because measuring cylinder can measure accurately, can measure the small differences in measurements. Here they need to add water to the 200 cubic centimeter mark, and they need to stir until there are no more air bubbles leaving the soil. So here they need to remove the air out, so they just added a known quantity, which is 100 cubic centimeter of soil, and then they started to add water until they got to the mark of 200 cubic centimeter. They started to stir the air, the soil. In this case, the water will get in and the air will get out of the soil. Read the new water level on the measuring cylinder. So now, after removing the air bubbles from the soil, they need to read the water level on the measuring cylinder. They need to calculate the volume of air in the soil. So how could they calculate the volume of air in the soil? Here, they need to take the original water level, which is 200 cubic centimeter, minus the new water level after stirring. So just subtract the original level from the and the new reading, which is the new water level after stirring. When they subtract, they will get a result, which is the amount of air. So here they have their results. They got the 200. Here the 200, which is the original reading after they added water, and then they took the reading. The Pavan got 190 and Paddle got 170. So the difference here is 10 and the difference here is 30. In this case, the volume of air is 10 for Pavan sample, and the volume of air for Paddle sample is 30 cubic centimeter. Okay, this is the air content, and how can you get the air content inside soil sample. What about the soil pH? We all know that every soil has its own pH, and we mentioned this before in our lessons. And we said each pH, each crop or a plant has its or the preferred or the suitable pH to grow. Ayo and Diane are at the same school. Ayo's family grow cassava and sweet potatoes on their farm. They tried growing peanuts, but the crop was poor. Diane's family grow peanut and soybeans. So here the cassava, it's kind of the of plants, like it looks like sweet potato. This is the cassava that grows in South Africa. Ayo and Diane ask a question. Why do different crops grow well on the two farms? The students wonder if soil pH is the reason. They collect evidence to test their idea. So how can they prove, or how can they know the soil pH? Let's see together. Ayo and Diane each take a sample of soil. They shake it up with universal indicator in a test tube. They record their soil pH values. So here they took samples of soil and they shake it with universal indicator. They added universal indicator to know the pH, which is alkali or acidic, and they record their results. For Ayo, she got 7.5, and Diane she got 6.0, which is like 6 pH is 6. So here we can see that this is alkali and this is an acidic. Ayo and Diane also collect evidence from secondary sources on the internet. They find out the preferred soil pH for 4 crops. A secondary resource could be the internet, which is something to help you or support your information or to support your experiment or your project. Could be a source, the secondary source could be a book, could be your teacher, your father, anyone knows real scientific facts and proved scientific facts. This is called a secondary source. So they collected evidence from the internet as a secondary source, and they found out more about the pH soils for 4 crops. They found about the cassava that prefer in soil or pH soil with 4.5 to 7.5, sweet potatoes 5.5 to 6.5, peanuts best is 6 pH of 6, and soya beans best in pH 6. So this is a secondary source, which is the information from the internet that they got. Ayo and Diane write an explanation to answer their question. Soil pH explains why different crops grow well on our farms. Diane's crops grow well on soil of pH 6. Ayo's crops grow in soil of higher pH, which is more alkali. If Ayo's family want to grow peanuts or soya beans, they will need to lower their soil pH by adding acid, which is canceling out the or a little bit neutralize it. So if they added the acid, they will neutralize this soil, and it will be good for growing the peanuts and the beans, soya beans. Okay, what about the color, the soil color? We might maybe we all saw the different soil colors. We might saw a red one, black one, brown, slightly brown, and sometimes yellow. So what causes these colors, or what's the meaning of these this color of the soil? Soil color provides evidence for the minerals in soil. Red soils may be rich in iron mineral. Humus-rich soils are black or dark brown. So this is the color. The color indicates the minerals content inside each soil type. So the red one, as you can see here in the picture, the red one contains iron mineral, and the black one, or the dark brown one, could be rich of humus. So this is the color of the soil. So now let's go to the summary of the lesson. More about soil. You can measure soil air content and pH. Air content by using known soil volume with the measuring cylinder. Then you have to add known quantity of water or volume of water. Then stir it and read the new reading or the new measurement. You need to subtract the original one and the new one from the original one. The reading or the result that you got, this is this is the air content inside your soil. And the pH, you can use an indicator and shake it with the soil, and you can see the color and indicate the pH. We studied also different crops grow best in soils and different pH. And red soils are rich in iron minerals, and the humus one are the black ones or the dark brown soils. This was all about the soil, or more about soil. I hope you understood the lesson. If you have any question, write it down. Please don't forget to write these notes in your notebooks, and don't forget the yellow box. I hope to see you soon safe, and we will meet in a new lesson. Bye bye.